So I'm here with Photon, our football robot from last semester. We're getting ready for a demo tomorrow, so I'm just making sure that it's all working. We had previously repurposed some of the talons on this shooter up here for one of our shooting prototypes, or late week 1. So I was just sitting around, redid all the can IDs, and just making sure that everything's wired back up. So, all the wheels are spinning in the right direction again, the pneumatics are all wired up, this carriage doesn't fall apart as soon as I fire it, so I think we're ready for tomorrow.
So right now we're at the technology demo for the Gridiron Challenge at the Texas Southern University, and right now Spectrum is demoing 2 of our robots, and we're showing our football robot from the NRG Football Challenge and one of our previous season robots, and we're shooting the footballs so the students can catch them, and meanwhile we're showing them all that we can do with technology and STEM, and showing them that there's a lot of opportunity for them, even if they do like certain sports, and then they can always have so many chances to learn about these things.
So this is in the process of building our climber. We're just going to go with a simple design where we have a small diameter bar running between these 2 posts with Velcro on the bar and the Velcro on the strap itself for climbing. We're going to mount a sprocket coming from the drivetrain. The climber will be powered from the drivetrain. We're thinking that the easiest way to do it is simply at the end of the match run the climber off of one side of the drivetrain, and so essentially just keep going forward. Once they're off the ground, just go forward on it. And we're not going to be using any gears, or initially we're not planning on using any gears along to gear it down. We're just going to run it directly off the Right now this is the mid-stage of our climber. As you see, we put on the 2 posts. We have a rod that the strap will be wrapping around in the giant bag. We have giant bag with a sprocket right here. That's going to run directly. Chains will run directly from this sprocket to the powertrain. 875. Deanne said that these were ½ an inch apart, and because I don't want to measure it, they're ½ an inch apart.
That was like really long and hard.
All right, here we go. Can't wait to start the video, guys. First, I'd like to welcome to check in here. We've got Team 3847 Spectrum. They're from Houston, Texas. Gentlemen, why don't you introduce yourselves for everybody?
Hello, I'm Alan Gregory. I'm the head coach for Spectrum.
I'm Will. I'm a senior and I do mechanical design and chairman's.
Cool. All right. Well, welcome to the show once again. Good to have you all on. Let's get right into it. So we saw a little bit of your climber there, and we saw a lot of awesome stuff with your demo robots. Let's talk about those actually really quick before we jump into the other stuff. It looked like you guys had a robot that throws footballs, and it looked like it was modeled after Brock Osweiler with its particular wobble.
So it's a little out of tune, but so that was actually for the NRG Robot Football Showcase that was held in September of last year. So they challenged 4 of our local teams to build punt, pass, and kick robots, basically.
Oh, cool.
But this weekend we were out at the Gridiron Challenge. It was like an event for kids in preparation for the Super Bowl that's coming to Houston. So there's been a few different things that are going on. So having a football throwing robot is nice for that.
Nice. That's awesome. We spent
our Saturday morning out there doing a little demo, getting kids excited about robots.
Cool. Well, Tom Brady's in town. Just have him take a look at it. I'm sure it'll make it fun. No, sorry, I couldn't help. All right, so let's get talking about the robot stuff. This year's robot stuff.
Absolutely.
First thing we want to touch on is your CAD model. Now we've heard that you got a full CAD model.
Yeah, and so we're gonna go ahead and switch over to that now.
What?
All right. So we should be in our CAD model now.
Oh, there you go. Wow,
yep.
Look at that.
All right. So this is pretty much the entire robot as we're about to send all of our sheet metal off to our sponsor tonight. So we have all of our subsystems in. We have our people producing drawings and stuff for it. But so basically the main concept is this guy folds up mostly. There we go. All right. So that's roughly starting configuration. So the balls get intaked. The mechanism intake will come down. There'll be more wheels on it. That's just how it's modeled. And they get sucked up through the belt path here, and they'll all be stored in the hopper along these bottom belts. The belts aren't modeled in CAD right now, and fed back into the shooter, which is in the tower in the back. Yep. So then we'll have the 3 balls wide coming up. They're all in a line, so each path are completely separate.
Okay.
So we'll actually have 3 different paths of balls coming out of each one of these little shooter hoods right here.
Wow. So this is a fairly detailed CAD model you've got your robot going on here. You've got all the way down to the blinking light and the radio and the people.
Yeah, absolutely.
Yeah, because this is basically the final version of our robot. So we have to make sure that everything fits. So if I didn't put the RSL light in and I didn't know that it fit, we just might not have an RSL light get cut out by our sheet metal sponsor. We'd have to like drill a hole and put it in somewhere random. Right.
So I got to ask. So there's a lot of holes already in the sheet metal. It doesn't leave a lot of room for more holes, I guess, if you have to make modifications. When you guys are in your final assembly or getting it from the sheet metal sponsor, how much work, let's say extra CAD, like outside of the CAD, has to happen to the parts?
Very little. The goal is to have everything. So even to the point of like these holes you see here that are like basically lightning holes in the side of our climber plate those are like backup plans on backup plans. Like this is a roller shaft that can be belted to this roller if we need to add like another roller to our elevator system.
Or we can just mount a VP on the side of the plate.
These are versaplanetary mounting holes here. So if we need to power the climber separate from our drivetrain, we could mount in a versaplanetary and chain up to this. So it's already CAD'd to the right chain spacing and everything. We don't want to do any of those things, but if we have to, it's ready to go.
Yes. Wow, that's actually very, very interesting. So I know that this will be like the 3rd robot you've built for the season, basically 3rd or 4th or what have you.
Yes.
So I guess the thing is, why so much detail? I know that you want to not have to drill so many holes, but is it that hard to get? I don't know how your sponsor works necessarily, but is it hard to get more sheet metal parts from your sponsor later on in the season if you have to, say, make a new upright there that the climber rests on, or?
Yeah, it'll definitely take more time, and also some of the changes we may not know about them until Thursday at an event, and we don't have time to make sheet metal changes then. But we could make the climber change if we realize the drivetrain thing isn't working. We just need to throw a sim on a versaplanetary into there. We could do that in an event in 20 minutes.
Wow, cool. So as we're kind of looking at this model, let's talk a little bit about your sheet metal process and your drawing. So you said that you're sending it out to the sponsor now, and you're also making drawings for everything. Can you kind of explain that process to us?
Sure. So basically, once we know all our geometry and we're ready to make our part, we start making the sheet metal part. We put things in assembly, make sure everything fits together, and by usually around this time, maybe a couple days later every season, when we think we have something that's final, we're getting close to our deadlines for when we have to start sending things out for powder coating and start assembling our practice robot. We call up our sponsor and say, hey, we're gonna start sending you some parts. Are you guys gonna be ready for us? And then the next step is these drawings. So these are the drawings that the actual laser cutting, the laser cutter and the CNC brake operators are going to look at when they're making these parts. So they're looking for, flange lengths to determine setbacks. They're looking for how big these parts are so they know where to put the fingers on the CNC brake. They're looking at, making sure we have the correct radii, we have the correct materials, we have the, what die we're using in their brake. Okay. All of that information is necessary for them to be able to properly punch in the information in the computer so that we get accurate bends out of the brake.
Wow.
And so in addition, we send them the actual drawing files and the actual 3D model files. We then send them a PDF of this as well, so they can just print them off easier. And the DXF files, which are the flattened sheet metal parts that they actually put in the laser to do the cutting.
Oh, okay. I was going to say, you got to send them a flat pattern at some point as well, right? That's cool.
Yeah,
wow.
So we send them 4 files for every single part that we want on the robot.
So that's a lot. That's a lot of documentation for all those different. I mean, the robot doesn't have a small number of parts for sure.
This one's about 40, a little under.
40 custom sheet metal parts. Yeah.
Yeah, that's a good amount of like drawings to make.
And we make them all in the last 3 days. We started Sunday.
Well, I mean, sometimes you got to crunch to put everything on the mill. Sometimes you got to crunch everything, get it through SolidWorks. So how many folks do you guys have working on the CAD? Because that sounds like quite a task, especially if you're not, doing this full time necessarily.
We
We
have
have 6 subsystems.
and 5 people doing CAD and drawings, not counting myself.
Wow.
So every subsystem lead for the most part will do their own drawings. We had one, so the guy who did our drivetrain also did the CAD for our climber. But that had the guy you saw in the video talking about the climber, he didn't do the CAD, but he did a lot of the physical testing and working out the geometry for us.
Yeah.
All right. So let's talk about your gear intake as we sort of see that on the model here. So it looks like it's kind of above where your ball intake is. Let's talk about that system, because that's kind of probably the most different part of this robot compared to other robots we've seen so far.
Yeah, so we're definitely going through a ground intake. We think it's going to be very important. I know you've been asking other teams. One of the reasons we think it's really important is at the beginning of the match, there are 3 gears already near your airship, the 3 that your team starts with, and you may not have partners who can score them. So if you can just set them on the bumper, have them drop them, and then pick them up and score them, that's going to cut your cycle times by a lot. So having a gear intake is going to be really useful.
Cool. So how does yours work? Give us the skinny on what this is.
So we were partially inspired by things like 2011 tube intakes and 2013 floor frisbee pickups. So we knew that there are ways to lift something up and put it underneath a top roller and pull it into ourselves. So we went through a couple different revisions. There were times where we were working with a single long roller and like some plywood, and then we switched to the carbon fiber you see now, and we've also had side rollers. But basically, the geometry you see here, we figured out, I think, starting Friday night. It started off with a couple drawings on the whiteboard, and then we put them into SolidWorks and started testing parts. But the idea is that the carbon fiber you see is a little bit ahead of the bottom of the wheel, so that the first thing that it really hits is the carbon fiber, and then the wheel starts compressing. And then hopefully that kicks it up onto the carbon fiber and can just yank it back into the intake.
Oh, okay. So with this, how do you put the gear onto the peg? Do you just sort of put it on top and reverse the roller, or how does it go?
Yeah,
basically. So it just rotates back up, and then we run the peg in, and then reverse the intake, and also tilt it forward so that we're pulling out as we're pushing the gear out.
Yeah, when this is stored in the robot, when it's vertical, this line right here is about 13 inches off the floor, which is the bottom of the peg. We can tilt it a little forward to make that hole come in a little bit easier. And then we just drive all the way in, start tilting down and ejecting, and it just puts it right on the wall.
Oh, okay, cool. That's awesome.
There's also, we've been testing, we haven't been able to do it on the real one, but we believe we can pull it out of the loading zone with this as well. So our mechanism intake that you saw at the top of the robot will actually knock down the gear. And if it all works in the geometry that we want, the gear will fall into that intake.
Awesome. All right, so let's talk about all the little details, because it looks like you guys have from a big perspective just about everything all set. So what are those little tiny problems you guys have run into so far?
So some of the things that we make sure that we add, especially in this year. So these the holes right here, those are going to be handles. So there'll be mounts on top of here that will screw on, that will 3D print, because you have to be able to lift your robot off of it. May be in the middle of the air. You're probably going to lift it to be able to pull the rope down. So we want to make sure that we can be able to manipulate this robot very easily. And you're not going to be able to lift under the bumpers this year on almost anybody's robot since they're so close to the ground.
Right.
So we're making sure that we're CADing in and making special sheet metal handles.
So we had tried steel cord back in 2014, but those just ended up tearing out because we were securing them with rivets, and they weren't the most comfortable things to hold. Right. So we're hoping that we can 3D print some ergonomic grips onto these, so that it'll be a little bit more comfortable in the hand and a little bit more robust throughout the season.
That's awesome.
Yeah, so a couple other details. So back here, we have a slot in the back of our bumper because our PDP is so close to the back rail that we wouldn't be able to put the wires. We wouldn't be able to get a screwdriver or tool in there without that. So we have a slot that lets us get into, if we need to do any maintenance on them, we don't have to take the back rail off or anything.
Well, that's good. You notice that now instead of when you're trying to build the robot.
Yeah, we've tried to think through all the maintenance stuff that we possibly can. There's still going to be stuff we run into, but a lot of it that we've thought into. Do you want to talk about the back panel?
Yeah, so this is our back panel. This is something we really started doing in 2014 on our robot infrared. But you'll see in the bottom left, we have a couple cutouts for Ethernet and USB pass-through, so we're not reaching into our robot to get to the RoboRio for programming. And then down the middle, we have slots for little tiny inline automation direct gauges and regulators for pneumatics. And then to the right of that, that's our pressure release valve. And to the right of that is a little cutout for a voltage display so that we can just check battery voltage by eye while looking at the back of the robot.
Oh, wow. So really all of these things, even though they kind of look like empty holes, they all have a purpose and a job.
Correct. Oh yeah. Yes. Even the weird TIE fighter patterns, those help us save the ounce. Those help us save ounces.
Yes, got to have them lightning holes. Cool. Well, let's take a question from the chat. Again, if you guys have questions for Spectrum or for any other team we've got on check-in, just type them in the Twitch chat with !Q, and we'll ask them to these guys. So we got our first question coming up here. How do you guys keep balls from jamming, especially with a 3-ball wide ball path?
So part of this is if we go pop back into the CAD model, we have a single red Andy Mark 2-inch wheel, and so that'll help balls keep from getting blocked in front of our shooter, hopefully.
But, yeah. So then there's one in the CAD. There's going to be multiple in the real one.
It's going to be a whole roller, but then they're partitioned into 3 lanes. So each ball gets held between 4 belts, and it says a unique set of 4 belts for every lane, and we're going to have Lexan dividers in between them. So the balls shouldn't be hopping off their belts. They shouldn't be, commingling between lanes. And they're about, I think there's about a 1/4 inch spacing in between them. So it shouldn't be too hard for them to not hit each other in the air. But then down below, we also have specific belt paths for each lane to help sort of funnel them more into a direct lane, I guess. Okay. And the plan is also to sort of, we're going to find some way to agitate our hopper a little bit, shake it up. That might just be running the mechanism intake against the hopper side and have the little rollers banging up against the Lexan to shake it a little bit.
Yeah, because the things that aren't in the CAD are the Lexan panel. So there'll be Lexan going right up behind the mechanism intake, and the mechanism intake will basically push it back when it's actually stowed. And then there'll be Lexan across the side rails as well to hold all the balls in.
Awesome. Well, guys, it's always a ton of fun to hear from you. I'm glad to see that your progress is this far along. I can't wait next week to see your finished robot, right? I don't know. No.
We'll probably hopefully getting parts back, hopefully.
Okay. All right. That makes more sense.
Next time you check in with us, it should have been Sheet Metal Christmas. So.
Yeah. Sheet Metal Christmas. Well, speaking of Sheet Metal Christmas, the next team up on our schedule is Team 148. 5803, my bad. Team 5803 is coming up next. They're from SeaTac, Washington. They're Team Apex. They're going to be joining us. But for right now, Spectrum, thank you guys so much for joining us. It's always fun to talk to you. And we hope you have a great Sheet Metal Christmas and a great sort of build and all that with your awesome looking robot.
Thank you.
Thank you.
Well, bye-bye for now. We'll see you guys in just a second.